Trig kids, this is section 7.4. It's the last section of the chapter. It's also kind of the most unpleasant section of the chapter, but I think I give you 2 days to work on this. So I'll give this video to you. It might be a little bit longer of a video, but you'll have a couple days to work on this homework assignment. So section 7.4 is periodic graphs and phase shifts. They call them phase shifts, and phase shifts mean horizontal and vertical shifts, which means you're shifting them up, down, and left and right. And you're doing this to all the trig functions, so the sine, cosine, tangent. I don't think they have you do any secant, cosecant, and cotangent yet, but your horizontal and vertical shifts. The transformations that we talked about, I'm just going to review that. Transformations, there's 4 of them, 1, 2, 3, 4. They are amplitude, which is how high and low the function goes. That's also like vertical stretching is another way of talking about amplitude. Period, which is the length of the cycle of what sine and cosine are. That's kind of like a horizontal stretch or compression. And then the last ones are amplitude period, vertical shift, and horizontal shift, which they will call phase shift a lot of times. Okay, so we did these 2 in section 7.3. Now we're going to do parts 3 and 4, vertical shift and horizontal shift. Okay. Vertical shift is easy. Horizontal shift is a little bit more unpleasant. So we're going to do vertical shift first. They start us off with the function of cosine of t, or cosine of x if you don't like that t in there. The normal cosine function starts here and it goes down and then it comes back up, and here is at 1 and here is at -1 and here is at 2 pi and here is at 0. Okay. Normal cosine and normal cosine, or normal cosine and normal sine functions. You should know what one cycle of that looks like. So kind of study those to try to get that down, that this is what cosine looks like, all right? Now we're going to do this stuff to it. So -2, +3. I think we already graphed this one at one point. I don't know. 2, the 2 right here means that my amplitude is changing. So instead of it being from -1 to 1, it's going to go from -2 to 2. So he's going to be taller, all right? And the negative is going to flip him around. So instead of starting up here and going down and then coming back up again, he's going to start down here, go up, and then come back down. Okay, but the 3 is going to move him up 3. So let's see. I'm going to take this guy and I'm going to flip him around so that we see what he looks like. So now he's flipped around, but now I want to shift him up 3 units. Okay, so this high point right here is at 1. If I shift him up 3 units, he'd be at 4, so he'd be like all the way up here in this D-ish area, okay? Down here, he's at -1, and I shift him up 3, so 1, 2, 3. Now he's here at 2, and he's going to go up like this, and he's going to come back down. That's what he's shifted up 3 units looks like, okay? I haven't changed the period of him at all. I've just changed his amplitude, and I've vertically shifted him, okay? And I've also reflected him, so he's going up and then down again. All right, so that's what example 1 looks like. Oh shoot, but they want us to do from -2 to +2, or -2 pi to +2 pi. So we've done from 0 to 2 pi, but they want us to go from -2 pi to +2 pi. So let's just draw one more cycle. There's what he's going to look like. From -2 pi to +2 pi. Wow, those don't look the same. They're supposed to look the same, but they don't. So pretend that they do. All right, make yours look a little bit better than I do, than mine does. And if you need to pause, go ahead and do so. All right. Now on to the ugly part, which is phase shifts. Okay. They do not. I wish they gave you a little box like they do down here. This is the nice box. This is the box that you're going to want to refer to. This orange one down below here. But they don't give you a box before this, so I'm going to give you the formula for phase shift. It's also written down here. Phase shift is equal to C over B. C over B. Okay, and I'll tell you what C and B mean. All right, an equation for a trig function is set up like this. It's set up in the form of A sine of B x minus C plus D. Okay, this A is your, I would write this down, A is the amplitude, D is the vertical shift. Okay, that's exactly what we just got done doing. So this is like your A value right here, amplitude, and this last one is like your D value, which is your vertical shift. Okay, B, we've already talked about B before. That is your period. Okay, so the number in front of there, to do period, you remember doing the 2 pi over B. That's how you determine your period. Okay, and then this C part right here, wherever I'm at, C part, this determines your phase shift. Okay, a combination of C and B together will determine your phase shift. So dissecting the sine function, or this could be cosine too. Each one of those parts, wherever the number falls, those determine your amplitude, your period, your vertical shift, your phase shift. Okay, so this sine function right here. Okay, we don't have a number out in front of sine, so that means my amplitude doesn't change. We don't have a number being added onto the end here, so there's no D, there's no vertical shift. But I do have values here for B and C, okay? B is just going to be 1 here because there's no number in front of T. So it's just going to be 1, and your phase shift or your C value is pi over 2, okay? All right, so C over B is what determines our phase shift, okay? Now, B, my B value, is this 1 right here. B is that guy. B equals 1, okay? Now, your C value is determined by this number here, but notice in the equation right here that C is negative. So whatever this number is here, we have to turn him negative in order to count that as my C value. So C isn't just pi over 2, it's negative pi over 2. We will always flip that symbol, okay? If he's negative to start with, he will be positive. Like over here, C will be positive 2 pi over 3, okay? So B over C. All right, so describe the graph of each function. C over B would be negative pi over 2 divided by 1, which is what C over B is. And this tells me that my phase shift is negative pi over 2. So this just means shifted pi over 2 units to the left. That's what that guy means, okay? You can kind of tell that from the equation up above here. If we just look at the raw problem here, we've had stuff before where we've had like, let's say x squared, and then we take and we do x minus 2 squared, okay? This means, well, let's do x plus 2. This means 2 units to the left, right? Because we do the opposite symbol. Well, that's what this means. We use the opposite symbol. We're shifting him pi over 2 units to the left, okay? That's what he looks like, all right? So you can kind of tell that to start with. All right, the second one, we're dealing with cosine. It really doesn't matter because we're not graphing these. They just want us to describe the graph. So what did we do to the cosine function to move this around? All right, since my B value is 1, and we're just doing minus 2 pi over 3, this just means that we're shifting him to the right 2 pi over 3 units. Okay, so he's just going to be the same cosine function but shifted to the right 2 pi over 3. Okay, now I did that kind of in my head, but let's go ahead and do the C over B trick so that we can verify that this is actually what we're doing. Okay, B is going to be 1 here because it's the number in front of T, and C is positive 2 pi over 3. Okay, we flip that symbol, all right? If we do C over B, that's 2 pi over 3 over 1, which is just 2 pi over 3. And since that's a positive 2 pi over 3, that means we're moving to the right. So to the right, 2 pi over 3 units. Okay, that's describe the graph of each function. We would take cosine, move him 2 pi over 3 units to the right. We would take sine and move him pi over 2 units to the left. Right? Okay, combinations. So example 3, combined transformations. All right, amplitude, period, phase shift of a function here. They have down here, they have the A, B, C, and D thing going on here. So there's sine and there's cosine, A, B, C, and D, all right? Amplitude, period, phase shift. They don't ask for vertical shift. Vertical shift would be if I was adding something out here. So we don't have a vertical shift. They don't even ask for it. They just ask for these three. So amplitude, period, phase shift. I'm going to do PS for short, okay? Your amplitude is the easiest one to identify. Aside from the vertical shift here, amplitude is very easy. Amplitude is 3, okay? Your period, okay? The formula for period is 2 pi over b. So I'm going to write that off to the side here. Now, look at this equation and try to determine what your b is. B is 2. That number that's in front of your variable. So b is 2. So to do period, it would be 2 pi over 2, which simplifies to pi. So my new period is pi now. And my phase shift is a combination of that c and b. It's c over b. Okay? C, I'll label these. This is C, this is B, this is A, and we don't have a D. Okay? C is 5. Actually, C is negative 5. Because I have to flip the sign. Okay? So if I do C over B, this is negative 5 over 2. So I'm shifting him 5 over 2 units to the left. That's what the negative means. Okay? So that's amplitude, period, and phase shift is what each one of those is. All right? So down here they have all of the information for finding each one of those: amplitude, period, phase shift, vertical shift. Now, the thing that I want to point out on amplitude is that it's the absolute value. If this would have said negative 3 here, that just means you're taking the sine function, and instead of him going up like this, he's actually going to look like this instead. He's going to go down first, okay? But that doesn't mean your amplitude is negative 3. Amplitude is like distance. You can't have a negative distance. So your amplitude is only the absolute value. It's only that positive 3 value, okay? Your period is 2 pi over b, which is what we talked about. Phase shift is c over b, and that vertical shift is just your d value. It's just how much you're shifting it up and down. We didn't have a vertical shift for this last one, okay? Let's see if we do for this one, all right? Describe the graph. Okay, we have all 4 pieces here. This is A, this is B, this is C, and C is actually positive 4, not negative 4. And D is negative 1, okay? So describe the graph. So I'm just going to talk about amplitude, period, vertical shift, and phase shift. Okay, and I'm going to abbreviate them like that, okay? Your amplitude is easy. It's 2. So he's done, right? Now, the next one that I'm going to do is I'm going to do vertical shift because that's easy. Negative 1 means that I'm going down 1 unit. Okay, I like to knock those 2 out first, okay, because they don't involve a formula. They're just the number that's standing there. So those 2 numbers are done, okay? I'm dissecting my problem here. Period, since we're dealing with cosine, period is 2 pi over b. If this was tangent, it would just be pi over b, okay? But this is 2 pi over b, and b is 3. So 2 pi over 3 is my new period, okay? And phase shift is c over b. C is 4, and B is 3, so 4/3. And since it's a positive 4/3, that means I'm going 4/3 units to the right. Okay, and I draw my arrow to the right. Okay, so now we've kind of figured out how to dissect this stuff. Now they want us to actually dissect it, and they want us to graph it, which is really pleasant. So amplitude, period, vertical shift, phase shift. I'm going to write these all off over here. Period. I would suggest that when you do these, you do the same thing. If I am going too fast again, please pause this video so you can kind of get your head on your shoulders, all right? Okay, here's my function that I have going on here, and it is a sine function. So I'm going to graph what one cycle of sine looks like. There's one cycle of sine. 0 to 2 pi. Try to get this graph kind of memorized so you know what sine looks like. There's what sine is, okay? All right, so now we're doing all this junk to it, okay? All right, A is here, B is here, C is here, D is here. All right, and C is actually negative 1 because we have to flip the sign, so I always change him, all right? Okay, amplitude. Amplitude is your A, but amplitude is not negative 4. Get that out of your head. Amplitude is positive 4, okay? So that means instead of going from 1 to negative 1, I'm going from 4 to negative 4. Holy crap. Oh, dang. I did this way wrong. I should have made my graph a little bit smaller. That's okay. That's okay. We'll just run into some words up there. That's fine. So 4 to negative 4. That's what my amplitude is going to be. Okay. Now my vertical shift is the one I'm going to do next. That's my D. So that means I'm going up 3. So instead of starting here at 4, I'm going to start 3 units above that. well, instead of starting down here, I'm going to go up. Yeah, I'm going to go up 3 units here, and then it's going to go 4 units above that, even higher. Oh my lordy. So its highest point will be up here at 7. Yeah, so I'll start here, it'll go up and then back down again. Okay, all right, yep. Yeah. Okay, period has to do with that b value. Okay, t over 2 means that my b value is 1/2. Okay, that's like saying 1/2 t. So period is 1/2, or b value is 1/2, and so I do 2 pi divided by 1/2. If I flip that, that'd be 2 pi times 2 over 1. And 2 pi times 2 over 1 is 4 pi. So now my period is twice as long. He's going to be longer. I'm going to put longer here. And this guy is going to be taller. Okay, so the 4 tells me he's going to be taller, and the 4 pi tells me he's going to be longer. Okay, the last one is my phase shift, and that's c over b. And c is -1, and b is, let's see, b is 1/2. Oh lordy. So -1 divided by 1/2 is, if I keep flip times 2 over 1, so that's -2. So I'm shifting him 2 units to the left. 2 units to the left, okay? Now, 2 units to the left, since I'm dealing with pi's over here, 1 pi is 3.14, so he's not quite a whole pi shifted to the left. Here's where pi would be. So I'm shifting him to the left, a value of 2, which is not quite 3.14. So a value of 2 would be about right here, where I'm going. Okay, so, this is going to be tough to graph. I might make it look easier than it actually is because I've done these so many times before, but this is hard stuff. So if you feel discouraged, don't be. You've got lots of practice to put in yet. So 2 units to the left. All right. We're starting. Normally we start at 0, 0. But we're moving 2 units to the left and 3 units up. We're actually starting right here. Okay. Then my amplitude means I'm going up 4 units. So I'm going to go up and I'm going to hit 7. But the problem is he's going to be longer now. So instead of him going out to 2 pi, he's going to go out to 4 pi. And he's actually not even going to go out to 4 pi because we've shifted him 2 units in. So he's going to end right about here because we've shifted him that far to the left. So he's going to end right about here. So he's going to go up, and then he's going to come back down, and then he's going to hit here again. So he's going to need to stop back here, and he's going to start right there, okay? The sine function goes up, and then it comes back down, and then it goes back up again. So if he's starting here and ending here right in the middle, he's going to cross. So right about there. So what I need to do is go up to 7, come back down again, and come back up again. So that's what my new function will look something like. Okay, something like that. All right, mine's not perfect, but it's pretty close to being what it should be. All right. Okay, identifying graphs. Find a sine function and a cosine function. So they want us to write 2 different functions for this thing. How can we write 2 different functions for that thing? Well, the normal sine function looks like this guy, and the normal cosine function looks like this guy. Okay, so what we're going to do is, if this is sine, we're going to look at this guy and say, okay, how have we shifted him? The normal sine starts down here at 0, 0. This guy is shifted. It says pi over 4 units to the right. So this distance from here, instead of starting at 0, 0, he's starting pi over 4 units to the right. Okay, so my sine function has been shifted to the right pi over 4. Okay, well, what that's going to look like is sine of x minus pi over 4. Because going to the right means that you do the opposite symbol. So sine of x minus pi over 4. We shifted in pi over 4 units to the right. One other thing that you might note is that his amplitude is actually 2 instead of 1. So that's going to be a 2 out in front. So this function could be represented by that sine function. Okay. Now, this is what normal cosine looks like. Normal cosine starts up here at 1, okay? So this part of my sine function should normally be over here touching the y-axis, okay? But instead he shifted over a value of 3 pi over 4. Okay, he shifted to the right 3 pi over 4 units, all right? So my cosine function is shifted to the right, actually 3 pi over 4, okay? Which means that my cosine function would look like x minus 3 pi over 4. Kind of like what the sine function looked like. Instead of minus pi over 4, he's minus 3 pi over 4, because he shifted that much further over, all right? And the amplitude is still 2 for the cosine function, so this function can be represented by sine or cosine. He's just going to be a little bit different in there because sine and cosine start at different places, okay? So either one of those could be used to identify this graph, okay? All right, which one of the following equations could be an identity? All right, so they're saying that cosine of this function is exactly the same thing as sine of this function. Okay, I'm going to go back and see if I can find, let's see, where's my graphs? Graphs of sine and cosine. All right, so sine is this guy, and cosine is this guy down here. All right, maybe I should just graph them here. Sine here, and cosine is this guy. Okay, so they're saying that if I take cosine right here, if I take the normal cosine function and I shift him pi over 2 units, okay, this piece right in here is like saying t plus pi over 2. I'm going to flip that around. This is like saying he's shifted to the left pi over 2 units. So they're saying, hey, if I take this guy and I shift him to the left pi over 2 units, that's the same thing as what sine is. If I shift him pi over 2 units to the left, that means he starts here and he goes down and then he comes back up. Well, kind of. He kind of is, except sine goes up first and then it comes down and then it goes back up again, okay? This one's going down and then up, right? If I shift him pi over 2 units, that means this guy is now shoved over here, this guy's shoved over here, this guy's shoved over here, okay? He goes down and then back up. So that's not quite the same thing. This is going to be exactly the same thing. If I negate him and shift him pi over 2 units, that means he'll go down first and then come back up. So this one is an identity. Okay, those two things are exactly the same thing because their graphs look exactly the same. Okay. All right. I'm going through this really fast, so I apologize if you're getting confused. You might have to rewind a little bit and kind of really ponder over some of this stuff. Which of the following equations could be a possible identity? All right, so this one I'm just going to do algebraically. I'm not going to look at graphs or anything. I'm going to look at what cotangent is. So cotangent, tangent, I think from chapter, chapter 6, we talked about the trig functions. Tangent is sine over cosine. Well, then cotangent is cosine over sine. Okay, and they're just flipped. So cotangent, I'm going to rewrite him down here as cosine over sine. Okay, and then on the bottom of that, I have cosine, and I'm going to put him over 1. Okay, so this is what I've got. Cotangent is cosine over sine. Cosine is cosine over 1. All right. Now, to simplify him, this is like keep, flip, flip. So I'm going to multiply by 1 over cosine and flip him to the top. My cosines can cancel out, so that's 1 over sine. So this entire thing right here simplifies to 1 over sine. Well, that's not the same thing as just sine, so this isn't true. But let's look at this one and see if this one is true. So here I have sine on the top, and I have tangent on the bottom. We said tangent is sine over cosine. So I've got sine over 1 on the top, and I have sine over cosine on the bottom. Okay? So I'm going to keep flip, flip again. I'm going to flip him to the top and multiply. So this is cosine over sine. The sines are going to cancel out. So I have cosine over 1, which is just cosine. And that's what I have here on the right side. So this one is an identity. Yes, we win. Okay? All right, I went through that really fast, but this is kind of a loaded section. So take a couple days to digest this and come back to the video if you need to. Help each other out. This is kind of rough stuff, especially when you get to combining all of this stuff. Actually, dissecting and finding the amplitude, period, vertical shift, phase shift, that's not the hard part. The hard part is actually having to graph it afterwards. So take your time on that and do the best you can.